Hi everyone, and welcome to another episode of Let's Talk Risk with Dr. Naveen Agarwal. Each week, we talk about a topic related to risk management of medical devices in a very casual and informal way. This is not a webinar or lecture. Rather, our goal is to talk about key topics and challenges in a very informal way and share best practices. I'm your host, Naveen Agarwal, and I'm the principal and founder at Achieve, where my personal mission is to help you achieve success in risk management. My guest in this episode is Professor Papademetris of the Yale University. He has recently designed a program in medical software and medical artificial intelligence to help industry professionals gain solid knowledge of this fast-evolving field. There are so many unknowns, and the technology is evolving very quickly. So it becomes very challenging for industry professionals to learn the cross-functional aspects of this technology when they try to use it in medical device design and development. We had this conversation as part of our weekly LinkedIn live audio series in front of a live audience. You're about to hear a recording of this conversation. So sit back, relax, and enjoy the show. Well, hello everyone, and welcome once again to our weekly Let's Talk Risk conversation. I'm so glad to connect with you once again. So with that, guys, I'm so excited to welcome Professor Papademetris from the Yale University. Normally, we don't get people from the academia, but I think this is going to be a fascinating conversation because Professor P, as his students call him, has developed a program in medical software, medical AI. And the reason I'm interested in this conversation and sharing this with you is we want to know how best to learn about these difficult topics, whatever our role might be. We might be an R&D role or quality role or regulatory role. AI, ML is coming, right? We know that. It's inevitable. The future is already here. So how can we prepare ourselves to this future that we are going to be living with? I think Professor P will have some insights to share with us because he has been thinking exactly about this. How to teach this course to people who have products to build. So this is not an academic activity, but more like a very practical way of learning about these topics. So hang in there, save your thoughts and comments for our open discussion. But I want to invite Professor P to just start by sharing a little bit about his background and what got him interested in building this program.
Yeah, so Naveen, thanks. I assume you can hear me okay?
Yes, I can hear you fine. Please, go ahead.
So welcome everybody. So I got into this part, like many of us by accident, right? A few years. So I've been working in software work from the research side, primarily in image analysis for the last, 20, 30 years. And at some point, somebody had the idea at Yale that we should do a medical software class for students to do projects. It sounds kind of fun. So that started about 2017. So, that one thing led to another. I started teaching the class. I realized that there was no teaching materials for it. So I started putting notes together. During COVID, the notes became a textbook. I then convinced Yale to let me record that on the Coursera class, which you can find online. Just look for me on Coursera. And then in the last couple of years with a new program here in biomedical informatics, we're beginning to build some programs for industry. This is a new certificate program, about 16 weeks on medical software and medical AI. And we're trying to create some overview. But in general, as I've talked to friends in industry in particular, the question is always, how do you get started in this business? I hired somebody from computer science in my firm, but there's an awful lot they need to learn. What is it? How do we train these people? How do we get them started? We have people who've been in industry 30 years, and this new thing called AI is hitting them. How do we bring them up to speed? So those are the questions we're grappling. The certificate program is one answer to this. I'd love to hear from other people what their companies are doing and how can be helpful. So maybe I'll stop there.
That's fantastic. And you guys might be wondering, how does it relate to risk, right? We are supposed to talk about risk here. This is Let's Talk Risk. And the answer is very simple. It relates to actually how we are going to build these products based on AI and ML, what kind of understanding we need to have. And Professor P, I would like you to share with me the analogy that you were sharing just before we went live. We are focusing so much on AI and ML, but that's not the only thing we need to build safe and effective products. So as risk practitioners, I think we need to have a little bit better understanding of this whole thing is. So it's less about the course and the program, but more about our approach to learning. This is what I want us to focus on. And that's where the connection to risk management is. So if you could go ahead and, help us really build that context for understanding AI ML as we try to use it for building safe and effective products, that will be useful.
So AI ML, the words themselves are controversial. Let's call them machine learning. That's a proper term probably right now. It's a set of technologies where we learn some rules from data, right? So in traditional engineering, we think about a problem, we come up with a design, we create detailed design as to how we will do something step by step. If more than 3, do this. That's traditional software engineering, if you wish. When you come to machine learning, we're dealing now with problems where we don't know how to do this, typically. And so we learn those rules from examples. So-called training data, we use algorithms to learn a model, and then we apply the model to new data. That is the basic principle of machine learning. The problem with that is, because we don't have explicit rules in place, we have less understanding of how the system works, which means we have a different way of thinking about risk potentially here, right? If we don't have complete understanding of how something will work. Now, if you think about the context, and this is what you're alluding to earlier, in the context of a system, let's take a piece of medical software. Let's say we're building something to detect lung cancer nodules from X-rays, or pick your favorite example. The AI/ML piece would be an algorithm that looks for that. The rest of the system is the thing that takes all of that and puts it in front of the user with all of the other things that need to happen. So the example I use is, think about a car and an engine, right? The AI is potentially the engine of the car. It's one component. It's a big component of a car, but there's a lot of other car left. Okay, steering wheels, seats, cup holders, interiors, mirrors, windshields. And the thing to remember always is that your users, your drivers, drive the car, not the engine. We're in the business of creating systems, of risk management, doing risk management on the system, not just on the engine.
Right.
Sometimes the solution to a risk management in AI isn't, let's make the AI better, but no, let's build safeguards outside the AI potentially to control for it. So that, I think, is the big picture. And again, remember, people drive cars, not engines.
Yes.
Not the AI, it's the whole system that's in place here.
I think that's a brilliant perspective, because you brought up the use of AI or machine learning for detecting, let's say, lung cancer. Now, the way we do it is, obviously important, but the most important decision is, do we have evidence of cancer or not? The diagnosis. It's a decision, and the risk is, we make a wrong decision. So at the end of the day, the focus of risk management really is on the system, as you mentioned, to make the right decisions. And this awareness, how do we start building this awareness from a learning point of view? Can you share some insights on that?
Well, so let's ask ourselves what could go wrong, right? The two typical errors that happen in these things, there's cancer that we missed, or we call something cancer that's not cancer, right? That's your typical detection problem errors. And so we have to ask ourselves, what are the trade-offs between the two? What would happen if we said that somebody has cancer when they don't have cancer? What is the next step? What would go wrong there? What would happen if we miss some cancer? If it's a small cancer, maybe it doesn't matter much. If it's a larger cancer. And so in typical development right now, when the FDA classifies these things, almost everything in this space gets classified or gets designed with a human in the loop type interface, where the computer is just suggesting something to a human who does a second read or does a first read and then looks at the output of the AI as a second. And that's, a classic risk minimization strategy, right? We don't claim that the thing is going to work by itself, so we are okay. Now, the question becomes now, how do we convey information to the user? Not just the answer, but, how did the thing come up with the answer? There's lots of words like explainability of AI, which mean most things to more people, and some of it is not quite there.
Yeah.
But there's a human factors component. How do we communicate between a computer and a user to allow the user to make a decision? Because ultimately, it's the user, the doctor, who makes a decision, not the system. The there to help the human. Now, who knows 10 years from now, how good would this be in an autonomous setting? But the reality right now is these are suggestions to a human.
Yeah. So that's the context. But I think the way you described actually helps us see the point of connectivity in this so-called car we're going to build. And that is why learning about AI ML is not about, let's say, Python programming or writing software, which is important. I'm not going to downplay that. But the why, the question of why, and I think this is what you focus a lot in your training, that you teach people about why we are doing things and what we are supposed to do. Can you say a little bit more about that?
Right. So let's take, the cutting hot thing that broke into us about a year ago. Let's call it something like large language models. People have heard of them as ChatGPT. These things like Q&A, chatbots that answer questions and often give very impressive answers. It's a big issue with plagiarism at university right now as we speak. Right?
Yeah.
So the question is, how do we take something like that? What if we are going to take something like that into a medical product? What is it that we need to know, right? And we need to know how to design software. It's going to be a piece of software. We're building cars, not engines, right? So we have to think about your usual software issues, the regulatory side of software, specification, design, usability. You need to understand AI because if you're going to do risk management of this thing, you need to know how it will fail or failure modes of this thing and be able to catch it. Some ways. You need to think about how software and AI come together in different ways. And, at the lower level, there's also use of AI tools to create software now, speeding up programming. There's things like Microsoft Copilot. That's on the side here, but it's part of the story. Right, and there's new kinds of risk management specifics to AI. There's AME 34971 that just came out, worth reading. Talk about people training is important. And then you need to think, and you really need to think, and that's not news to anybody in this business, about the application area, right? These are not generic tools that we create.
Yeah.
It's a specific use case. And in a specific use case, what should we worry about? Because maybe there's a big problem we don't worry about in other cases. But in our case, this is the error we can't afford to make. And that's where we put our time. And maybe this is an error, So people who do AI research focus on accuracy exclusively, right? We get publication, 90%, 91%. For accuracy is good. It's a step zero in the process. But what's the impact of that 9%?
Yeah.
Right?
Yeah.
If I'm building a diagnostic and only 1% of the population has the disease, I could get 99% accuracy by calling everybody healthy. I don't need a fund.
That's interesting.
So what is the cost of a mistake? What are the mistakes I can afford to make? What are the mistakes I can't afford to make? That's our challenge at all.
I love it. So as risk practitioners, actually, we need to have this big picture in mind, but also have enough understanding of the technology, of the different parts of it, that we can ask intelligent questions and have this discussion. That's what I'm hearing you say. And it's a language. It's people speak different language. Regulatory speaks a different language. Quality speaks a different language. Software people speak a different language. But we are, as risk practitioners, we have to really strive hard to be multilingual.
Right. I mean, that's true for any complicated operation right now, right? The biggest challenge we face is not just being good in our discipline. I would say that's relatively easy, but how to become at least competent in other disciplines. We've done what our software engineering colleagues, our machine learning colleagues, our quality colleagues are worrying about. What is driving their thinking? What are they worried? What is the form that they need to fill? Let's be pedantic sometimes. What evidence do we need to provide for them? What are the real problems as opposed to the things that we just have checklist out? Sometimes, sort of process are behind in some ways. So those are the issues we have to worry about.
That's wonderful. This sets the stage really well for our conversation. I know some of you are already requesting to speak. So I think unlike our previous conversations, what I would like to focus on, guys, are sort of challenges that we face as risk practitioners in learning, in building competence, in building capability, in the context of software or AI that maybe we can learn a little bit from Professor P. And also maybe think about, how can maybe a university support your learning and education journey, because it's generally not a norm. I think the norm, we don't see universities offering sort of really practical training for people at the mid-career level. So it'll also be nice to hear your views on how maybe a university can help people build this competence. So our conversation today, I want to frame this not as a problem-solving technical conversation, but more like overcoming challenges to learning, because we have to learn fast. With that context, I would invite Ryan now to share what he has in mind. But guys, don't hold back. Raise your hand. I can bring as many people as they are interested. Don't wait for your turn. It takes me a while to bring you up here. So Ryan, you are on. Please share what you have in mind.
Hello, Naveen. Can you hear me?
Yes, I can hear you fine.
Okay. So to your point, I'm not trying to solve a problem, and I'm not asking for an answer. I'm basically making a rhetorical comments. Number one, what's the difference between software development today and then applying AI to more or less automate that? And the rationale for my question is, if you have bad software development techniques, if you develop software poorly, in other words, there's a lot of people who develop software very much like Van Gogh. It's an art form for them, and they don't really have good techniques. And this is evident by your iPhone or whatever, where there are constant updates, and they're not improvements; they're bug fixes. So how do we find out how to teach AI correctly? And secondly, how do we identify when it's not correct? So this is one point, because it all leads to risk, obviously.
Yeah.
And the other point is, and this is more of a personal opinion, whenever I hear people talk about failure modes, the first thing they jump to is, how can something go wrong? And this is something that Dr. P also had just mentioned. You look at how things can go wrong, and the severity of the chains of effects, right? In other words, this happens, this happens, this happens. This is all great, but the problem most people will run into, if you don't know how it's supposed to work in the first place, how can you talk about what can go wrong? And in software particularly, there's a misconception that software will work every time the way you code it.
Yes.
All right. So you not only need to identify what it is supposed to do, you also need to define what it's not supposed to do. And this is something that software people resist, because there's state changes, intended state changes.
Yeah.
But there are also non-permissible state changes, and they completely fight this argument. But when software, fails because of a hardware issue, software may come up in an unknown state, and it just starts executing code.
Yeah. So this is, I think, Ryan, you have really, really articulated some of the key points here. And first of all, I really appreciate this level of insight that you are sharing with us. To your first point, I think that's what I would like to ask Dr. P about. Building good habits is also important. The process of developing software is important. What are some of the good habits that we can learn? And is that part of our, and how do we even get trained in that? Are we people talking about, teaching people how to have good habits?
I mean, the reality of the matter is, so here's another challenge, right? The level of procedure, process, skill is very different when you go from a small piece of software to a large piece of software, right? And one of the challenges in a university setting is most students don't have enough time to write anything huge.
Yes.
So you can get away with sloppy thinking in small scale code that doesn't work once you get, past a certain number of lines. Yes.
Yeah.
Like all of a sudden, size is a problem in its own ways. So I had two things here. One is AI right now as a tool for software development, as opposed to AI incorporated into software, right? So let's break those things up. a lot of what that does is accelerate low-level processing right now. So write me a function that does this. You can get a function like Microsoft Copilot will do it for you, and then now you have to edit it. So you have to treat that type of AI as a very junior programmer that you're going to then, code edit, review, check, verify before you allow that code to get into your system. The trouble, of course, is once start people believing that that's infallible, then you'll end up with a lot of bad code that's going to take forever to get out. That challenge. In terms of risk and, AI code, the other problem, of course, here is that we don't have a complete understanding of what the code does. So all of those definitions of how the system works, we don't understand how the system works. So the example I give sometimes to my students is the way we look at problems with AI is not unlike the way we look at, say, cancer as a disease. And we do biopsy and we try to poke here and see what we can find. And we do another test here. And given enough statistical tests, you have some statistical view of, well, it mostly looks like this works, but we're not 100% sure. We'll never have that level of certainty, which means that maybe for some applications, this is not for it. And in others, you're going to have to sort of train people to use a tool that's not 100% going to be correct, and with how we train people to be more on the approach. On the flip side, for some applications, the performance benefits of going to AI are huge. Right? It's not just, I can tell you all about the problems, and you'll say, well, why are we bothering with this? Well, we're bothering with this because our detection accuracies go from like 50% to 80%.
Yes.
There's still another 20% that could cause us lots of trouble. So that's the challenge we face.
I think you make a good point, Professor P. And one thing I will share with you guys is, if you look at some of the recent approvals or clearances or de novos that are coming out of the FDA, and I've gotten into the habit of reviewing that material, a lot of material out there. I think you will begin to understand the trade-offs that we are making today and the trade-offs that are acceptable from a benefit-risk point of view. Sometimes 85% sensitivity might be good enough. It depends. So if you read that, you will get a sense of the tolerance of uncertainty. And I think that is where some of the practical sort of understanding can help you in making those decisions with your products. Ryan, you also, first of all, hang in there. I want to invite more people.
That's fine. I do have one other comment to Professor.
Go ahead. Before you go there, I want to just do a call out, guys. Please don't be hesitant to raise your hand. The more people who share their insights and perspective, the better this conversation would be. So with that, Ryan, go ahead and ask your follow-up question.
Okay, so you mentioned in a university setting, the difference between a large-scale project and a small-scale project is very different, and then students don't have the time necessarily to go into larger things. I would argue against that because there are techniques that help take a large project, assess what the important pieces of that large product are, in other words, where you should be focusing, and then you can scale the same procedure, the same thinking, the same methodology to different parts of, if you think of a hierarchy diagram, you think of like an organization chart, right? You might look at the CEO type level, or you might be looking at the low level of, an administrative type person, right? And anything in between. But the point is, it's no different at any one of those scales or at any one of those levels. It's a matter of scoping the work. So if you want to talk about inputs, the process, and outputs, if you have a stable set of inputs and a stable process, the output is pretty predictable. Now,
so I think you're describing a process-based approach, and I think the point I was going to make here is, hey, in a real-world scenario, we are running against deadlines, tight timelines. In a corporate world, everything has to be fast, and sometimes we find ourselves in the same situation that, hey, just do what you need to do it quickly and move on, and we don't really take time to use this process-based, a very disciplined approach. So
it's not so much that it's no different. It's you have so much time or little time, and you have a task to do or tasks, you identify which are the more important tasks, and you
Got you.
focus on those.
Got
So it's time management. It's not, but you're making these decisions consciously, as opposed and with data, as opposed to just, oh, I think,
Yes, yes.
which is what happens today.
Yeah.
A lot of people, oh, I think this is more important. Okay, I'll shut up now.
No. I think the point you're making is this is what I meant by good habits. Like if you have good habits, you can do a task fast. Fast doesn't mean sloppiness, right?
Yeah.
So I think that's a good point, guys. We still have about 5 minutes or so. Please don't hold back. This point that we wanted to learn a little bit from you today was about what is your expectation or view, or what would work for you from a training and learning point of view. I think that is where people like me or Professor P in different situations who are passionate about sort of coaching people and training people can learn a little bit from you. So don't hold back. You have a lot to contribute and share as well. With that, we still have 5 minutes, guys. So again, please raise your hand and share. Otherwise, I'm gonna give the space to Ryan once again to share what he has in mind. Ryan, go ahead. You have the floor. I'm inviting Roger. Ryan, if you have anything else to add to that, otherwise I'll go to Roger.
So for the academic world, a lot of material that I've seen in the academic world with my particular field is done by people who are not practitioners. It's done by theorists. Mm-hmm. And that's okay, but the key, I think, is to take a look at those people that are in industry, see what they've published, and then contact them directly for, hey, we'd like to include this particular topic. You've written something on it, and you can get a cross-section of different perspectives. So
wonderful.
That's the point
Brian, if I can respond to that for 2 seconds.
Yes.
One of what we do for this certificate program is that I interviewed a number of colleagues from industry, so we use the full interviews as supplementary material, and the plan is for the live Q&A sessions to have industry guests to help answer questions, because real-world expertise matters a lot, and that's something, of course, we in universities don't quite have. I mean, some of us do some consulting for industries, so we're quite second-hand. But yeah, I fully agree with you. I don't think this is something that universities...
So Professor P, I'm going to put you on the spot by saying that, hey, if anybody in our audience wants to raise their hand and be a part of your interview series, can they reach out to you?
They can. I mean, we have enough recorded to keep us going for a while, but I'm always looking for people, like experienced people who have lots of years with something to add. If you go on YouTube, Naveen, maybe I'll put a link later.
Sure.
You'll see the first 3 or 4, and we range from lawyers to AI practitioners to everything in between, because I think that's the span of expertise that, we could benefit from. And so,
great. So guys, again, don't hold back. Be a part of this whole process and community. Roger, with that, you're on. Please share what you have in mind.
I'm really out of my depth here, but I'm going to plunge in anyway. So I was listening to another podcast, and they were talking about the importance of the data with which you train your AI on it. And I thought this would be kind of important in medical devices. And thinking about what Professor P said about how no one understands really what these things are. Can there be some educational opportunities for students coming up having to do maybe more with the training, which it maybe gives them an insight or a better appreciation of what can go wrong? And maybe just ask for your comments on this.
Yeah, I mean, look, we are in a place, traditional software development, right? We would use a little bit of data for testing at the end, but the reality was data was second to code. We are now moving to a reality where the code is often pretty standard, and what makes the difference is the data. And so data is critical. If you don't have the right population coverage in your data, you will get biases in there. If your data comes from so let me give you at least one thing that I look for as an imaging person. When I see a study, at least an academic study, and all the data comes from a single site and a single scanner, I say, okay, that's not great, because you have overlearned the characteristics of that one site. And we see that all the time. So it's going to be, it's a lot of the same thing. Is this data, does it cover the span of the cases that I'm interested in? Now, with newer techniques like ChatGPT, where we don't even know what the data is. How does one regulate that stuff? It's an open question, and this is big debate as we speak right now. But yeah, data is almost the most critical part of this process right now, almost more important than any code, or beginning to be more important than any code over time.
Well said. And I know I'm aware of a lot of work being done. I think we can expect a lot of guidance documents come out from the FDA or other agencies that will help us really think ahead about what data we would need as a training set to remove bias. So that's actually another big topic for us to talk about in maybe future conversations. But look, guys, I think we have run out of time. As always, these discussions have their own speed. I would like to give Professor P just a minute or so to collect his thoughts and share some 2 key takeaway points with us. But in the meantime, I'm going to share with you just a few announcements. First, I'm so excited to tell you that I'm launching a monthly podcast series. This is going to be different. We're going to continue these conversations every week. But my monthly podcast is a sit down, not a live conversation, but a deep dive into a topic with the goal of sharing actionable insights. And the first episode has already been launched. I did this conversation with Vincent Cafiso, who's in the audience today, by the way. Thank you for joining, Vin. You shared a lot of great insights. So I would like you guys to go check it out. It's on the Let's Talk Risk website. You can find that in my LinkedIn feed as well. And finally, I want to again do a call out. All of us have something interesting to share. This requires no preparation, no deep discussions or slides or presentations. If you would like to be a guest on this program, please reach out to me because I know all of you have great insights to share. With that, Professor P, if you could just share a couple of key takeaway points so that we can remember this conversation.
Yeah, no, thanks, Naveen. This is so great. Thanks to everybody for asking questions and making comments. It's a challenge to see how we keep up with something that feels like it's changing very fast. ChatGPT was released into the world November 30th, 2022, if I'm not mistaken. And it's already asking us more questions as to what we deal with things like large language models, foundation models. Those are going to be challenges. We're in a new game, huge new opportunities, right? I mean, take my own field of image analysis, like nothing from before deep learning ever gets thought about anymore. So we have huge new opportunities. And unfortunately, we have these very unstable methods that will fail and will fail maybe in non-obvious ways and in non-obvious setups. And, that's our challenge, how we harness the power of this new technology while also not, letting it take us in places where we don't want to go. And, that is a challenge of the future. How do we manage the benefits of AI while controlling for the risks of it? And we can bury our heads under the ground and say, oh, we don't want to touch it, but we'll be missing out on a lot.
Yes. But, what it means basically is for us to be willing to learn fast and, make mistakes, learn fast and do it as best as we can. The problem is it's really quite fast. So we have to get better. This is going to be a sprint. With that, guys, thank you so much again for joining. Next week, I'm so excited. I'm going to have a gentleman share a patient's perspective with us. We hear about a technology side a lot, but do we get to talk to our patients? I think next week we're going to have an opportunity because I'll have a guest who will share his experience as a patient with a medical device that he has been using for a while now. And I think it'll be pretty interesting for us to just hear that out. I invite you next week. Again, the announcement is out on LinkedIn already. Please join us. With that, thank you again. I'll see you next week. Have a good one, guys.